outcomes and their probability, like tossing a coin. So if a coin is tossed, you will get heads and tails. So only two outcomes. So the probability will be 1 by 2, 1 by 2. And if you list the outcomes with the probabilities in a table format, you call it as a probability distribution. For example, in this case, 0 heads, 1 head. Okay, so this getting 0 heads probability will be 1 by 2, and getting tails probability will be, getting your head is your success, you call it as success, so it will be 1 by 2. Total probability is 1. In any case, the total probability will be equal to 1. So when you this is general, and if a coin is tossed n number of times, it is 2 power n. If it is 3 times, 2 power 3, like that. So then we call this as characteristics of probability distribution. Sum of probability is equal to 1. In any case, the sum of the probability will be equal to 1, and even outcomes are mutually exclusive events. So one thing is outcomes are mutually exclusive events. The list is exhaustive. They call it as list as exhaustive. That is not needed. Sum of probabilities, you just take it as equal to 1. Okay. And one more thing is, we have two variables. Now we go to concept of random variables. Random variables. What is random variable? Is a quantity resulting from an experiment that by chance can assume any different value. It is the result of an experiment. A quantity resulting from an experiment can by chance can have any different value. In this we have discrete random variable and continuous random variable. So discrete variable is a variable which can assume only clearly separated values, usually the resulting of counting something, result of count, like size of family, number of heads, etc. These are examples. So this is the result of count. Anything which is count, like number, which says number of heads, number of counts, or size of family, like it is a discrete random variable. And continuous random variable is random which can assume any infinite number of values. Within a range. Infinite number of values within a range. Example, height of a student, salary, within some range. So these kind of variables is called continuous random variables. And discrete random variables, example, you can see number of students in a class, or number of children, number of cars, anything which says number of is a discrete random variable. And a continuous random variable, a random variable which can assume an infinite number of values within a given range. It is usually the result of some type of measurement. Normally we measure continuous random variables. So like the length of each song, weights, heights, amount of money, these are all continuous random variables. Now we go to mean of a discrete probability distribution. So the mean, as you know, it's a location of a central tendency, is a typical value used to represent the central location of a probability distribution. The mean is, we can call mean also as expected value, and we denote it with E of x. It is given by sigma x p of x is equal to x. So multiply the values into its probabilities, you will get the expected value or mean of x. Okay, like if it's a probability distribution like this, it is given as x values are given and p of x is given 0, 1, 2, 3, 4. This is 0.1, 0.2, 0.3, 0.3, next to 0.1. Total probability, if you add, it will be 1. So what we have to do to get the mean of x is 0 into 0.1 plus 1 into 0.2 plus 2 into 0.3 plus 3 into 0.3 plus 4 into 0.1. Thus total value is equal to which mean value, which is given as 2.1. So multiply x with along with the probabilities, you will get the mean of x. This is also normal question, they'll ask. So get the mean and variance. How you will get the variance of the probability distribution is variance of we call it as the discrete probability distribution. It's not a continuous, it's a discrete variables we are talking about. So it is given by first what we have to do is find mean of x, then we have to square x. So normally if we are given with ex, then probabilities, first we will find the mean, which is given as sigma x p of x is equal to x. Variance is given by formula sigma x square p of x is equal to x minus mu square. So this mu you will get by finding the mean. Mean is nothing but mu. So this we have to square the each value of x and multiply with their probability. So in this case, above case, if it's x p of x, x values are given as 0, 1, 2, 3, 4, and this is 0.1, 0.2, 0.3, 0.3, 1. Total is 1. So you have to square this one. 0, 1 square is 1, 2 square is 4, 3 square 9, 4 square 16. Next x square p of x is equal to x. 0 into 0.1 0, 1 into 0.2 0.2, 4 into 0.3 1.2, 9 3 is 27, 2.7, 16 into 0.1 is 1.6. No. 0 into 0.1, 1 into 0.2, 4 into 0.3, 9 into 16.1, 1.6. Total this value 1.2, 1.4, 1.4, 2, 3, 5.7. So variance formula is sigma x square p of x is equal to x minus mean square or mu square. So in this case 5.7 minus earlier case we have found the mean as 2.1. So this is 2.1 square. So the answer is variance is 1.290. To get the standard deviation, equals standard deviation of random variable x, of discrete random variable x, is given by square root of variance. This is square root of 1.290. You get it as some 1.136, and you don't have any units for this. So this is mean of a random variable, then variance and standard deviation of a discrete random variable. That's it. Then we go for a binomial probability distribution. Got it? Binomial probability distribution. For a binomial probability distribution, there should be only two outcomes. There are certain rules. You should have only two outcomes, which is success and failure. And success is denoted with Q, failure is denoted with Q. And we have fixed number of trials. Denoted with n. So normally binomial probabilities and success remains constant from trial to trial. This P remains fixed from trial to trial. Means if I toss a coin 3 times, so the probability of getting a head is my success. So that 1/2 remains same, constant throughout my experiment of tossing a coin 3 times. So for example, if I say I am tossing a coin 3 times, and n is equal to 3, and probability of success is probability of getting head. That is 1/2. So how you will get the probability of failure? Normally 1 minus 1 by p. 1 minus 1/2, that is equal to 1/2. Okay, so this is you can get the binomial probability with the following formula: P of x is equal to x is equal to ncx p power x q power n minus x. This is the probability. You can find it for a binomial distribution. So these are conditions. There should be two outcomes, the fixed number of trials, and P remains fixed from trial to trial. For example, if I toss a coin 3 times, they will ask like this question: probability of getting heads exactly 2 times, exactly twice. So when you have to remain certain wordings. If it's exactly twice, we have to find P of x is equal to 2. If they say P at least 2 heads, this is what? For at least 2 heads.
Greater than or equal to.
At least 2 heads. No heads. P of no heads.
X equal to 0.
0. That's it. This all you can find it out. We have calculators to find the probability also. In Excel also we can find the binomial probability using binom.dist function. In Excel also we can use to find probability. Mean of a binomial distribution is given by NP. N into P. Variance is given by N NPQ. And standard deviation of binomial distribution is given by square root of NPQ. So in our case, the mean will be n is 3 and probability is 1 by 2, 3 by 2. This is 1.5 and variance is NPQ, 3 1 by 2 into 1 by 2, 3 by 4 is 0.75.
Okay.
Standard deviation is square root of 0.75 of random discrete random variable. These are all discrete random variables. So this thing part. So these are assumptions. There are only two possible outcomes, as I said. On a particular trial of an experiment, the outcomes are mutually exclusive. The random variable is the result of counts. So normally counts, and each trial is independent of any other trial. They are not dependent. Each trial is independent. These are binomial distribution characteristics. As I said, the outcomes of each trial is classified into two mutually exclusive categories. If I get success, the other one will be only failure, only two events. And the random variable x is the number of success in a fixed number of trials. The probability of success and failure stay the same for each trial. The trials are independent. These are assumptions. As I said, for binomial distribution formula, NCX p power x q power n minus x. Here C denotes a combination, n is the number of trials. So this is the binomial probability distribution. Example, you can see there are 5 flights daily from Pittsburgh via US Airways into the Brantford Regional Airport, Bradford. Suppose the probability that any flight arrives late is 0.20. What is the probability that none of the flights are late today? So in your case, the probability will be P is equal to 0.2, N is equal to how many flights? 5 flights. So what we need to find? P of x is equal to 0. We have formula P of x is equal to NCX p power x q power n minus x. So this is pi c0 p power 0.2 power 0. Next 1 minus 0.2 is 0.80. 5 minus 0. NC0 is 1, 5C0 is 1, 0.2 power 0 is 1. This is 0.8 to the power of 5. The resulting answer, you can find it out. So this is binomial probability distribution. And as I said, mean of a binomial distribution is NP. Here denotation, they are denoted with pi. Normally they will also denote with pi or p. P is fine because probability of success, and variance is NPQ. So this is how we will find the mean and variance of a binomial distribution table. Like in the normal questions will be like this. A probability distribution table will be given. They'll ask at least to find one of the missing value, or mean of a variable, random discrete random variable, or a variance of a binomial random variable. We can also use tables, but not needed. We can use either formula approach, or you can use calculator. In a TI-83 calculator also you can find the probability. Excel functions you can find the probability. So this is binomial probability. If they ask like this, you can find it out like P is equal to, see this example, using the Excel function, binom disk is the function. What you have to give, x, n, pi, false. So if I want to find it out for x is equal to 0, n is equal to how many cases? 6. P is equal to 0.05. What we have to type in Excel is equal to binom dot disk. Okay, and we have to find it out x value. X value for this, here it is 0. X value, these are x value 0, and next comes n values. For n is equal to 6, P is equal to 0.05, and x is equal to 0. Excel formula binomial dist 0, then 6.05. The other statement you should give it as false. You will get for 0, and then drag it for other values. You will find the probability distribution tables.
For others.
3. If they ask rounding, they'll ask you to round to 3 decimals or 4 decimals. Normally 4 decimals they follow. If they specify 3 decimals, you have to round it off to, if 0.2367 you got something like this. This value how much you got? 0.7351. This is 4 decimals. If they ask you to round to 3 decimals, it is 0.735. This is rounded. They will specify to how many how many decimals it has to be rounded.
Okay.
So this completes your binomial distribution and discrete probability distribution. Any doubts? You can also use megastat that are not needed. With simple calculator, you can find it out actually. So this if you sum of the total probability, it will be one what it. Cumulative binomial distribution probability distribution is nothing but you add the probabilities next to probabilities. So here you can see what is the probability. The front seat occupants in at least 7 of the 12 vehicles are wearing seat belts, having wearing seat belts or not wearing seat belts, only 2 events, and n is equal to 12, and here success is getting at least 7. So P of x is greater than or equal to 7, you have to find it out. So 7, 8, 9, 10, 11, 12. So in any case you have a complement event and this thing I said the other day. So for example, if n is equal to 5 and if I need x is equal to 2 and P of x greater than or equal to 2, that is getting 2 heads in at least 2 heads, getting at least 2 heads, this is equivalent to, which is nothing but what? P of x is equal to 2 plus P of x is equal to 3 plus P of x is equal to 4 plus P of x is equal to 5. You have to add all these probabilities, which is nothing but 1 minus P of x is equal to 0 plus P of x is equal to 1. This is by complementary law, as we have discussed earlier. As I said, P of A plus P of A complement is equal to 1. So if I want P of A complement, you can get it as 1 minus P of A. So that is how I did it. So greater than or equal to 2, 3, 4, 5. Instead of finding 4 probabilities, if I know the 2 probabilities, if I subtract it from the 1, you will get the required answer. So P is equal to 1 by this is binomial distribution. This completes binomial distribution. In any case, if they ask at least, at most, that words you have to take care of. None of the events you can take. Stop. Stop it.